Hi guys, in this video I explain recursion. I use an example to sum up the values from 1 through n. I first go over an iterative solution and then I explain the recursive solution. Let's start out with an iterative solution. So in iteration there are always loops. In this case I declare a method named SumIterative with a single parameter of type int named n. N defines the maximum value that I want to sum up to. Now I also declare a local variable named total and I initialize it to 0. This will store the current total as I'm going up the values from 1 to n. Now I use a for loop with a counter variable named I initialized to 1. I want to increment I as long as I is less than or equal to n. And in each iteration, I increment I by 1. This loop will give me the values from 1 all the way through n. Now here I have the values, so it would be 1, 5, and then all the way up to n, whatever n may be. Now in each iteration, I add the current value of I to the total. And at the end of the loop, I return the total. And this should be the iterative solution. So let's try this out. Let's declare a variable named n in the main method. I initialize n to 5. Then I declare a variable named sum1. I initialize it to the return value of SumIterative, and I call SumIterative and pass n to it. Finally, I output the value of this result. So this is the iterative solution, and I output sum1. Let's run this program. And here we get 15. Now let's see how this works. We pass in 5 to the method. Then we declare total. So total at this point is 0. We initialize I to 1. And then it checks the condition. Is 1 less than 5? This is true. Then it adds 1 to the total. So in this case, the total would be 1. Then it increments I by 1. So now I is 2. 2 is less than 5 and adds 2 to the total. So the total at that point is 3. Then it increments I by 1. I is 3. It adds 3 to 3. It increments I by 1. So I is now 4. It adds 4 to 6. And finally, I is 5. It adds 5 to 10. And the total will be 15. So in this case, it summed up all the values to 5. N was 5, so the loop would stop here. It would increment I to 6, but this condition is false. So it stops and returns 15. Now this is one way to implement this. Another way to implement this is going backwards. So here using a loop, for loop, but initializing I to n. So going backward, I initialize it to n and then I count down all the way to 1. So I want to repeat this loop as long as I is larger than or equal to 1. In each iteration, I decrement I by 1. And the loop's body is the same. I add the current value to the total. So let's run this program. And here we see we also get 15. So in this case, I have again I start with 5. I count down all the way to 1. And so my total would start out with 5, then adding 4 to it will be 9, adding 3 to it 12, adding 2 to it 14, and finally it would be 50. Both of these are valid solutions. However, both of these use loops, so they are iterative solutions. Now the reason why I show you the reverse loop starting at the largest value and counting down, because this is closer to the recursive solution. So let's start next to look at recursion. Now recursion never uses loops, or rarely uses loops. There are recursion where we can mix the two, where we can use iteration and recursion, but many recursive solutions simply don't use loops. Now there are three things that are required for recursion. The first thing is a method. Second thing is a base case. This is kind of when to stop the recursion. So this is kind of like the condition in a loop when we want to stop. And the third thing is a recursive case. The recursive case is essentially a repetition, what we want to repeat. Now let's start out with a method. In this case, the method will look familiar. I will call it some recursive, and it has a single parameter named n as well. So this is almost the same as the iterative solution, just a different method name. So we have a method. Now the way recursion works is by calling the method from in itself, so that we call it over and over again, and at some point we want to stop. Now let's first look at when we want to stop. So we pass an n, and what we want to do is count down n all the way to 1. And in each time that we count it down, we call this method. So let's start with the recursive case. So here I call some recursive, and I pass an n. Now doing this, we have recursion, but we have an infinite loop, right? We pass in 5, we call it again, pass in 5, pass in 5, and nothing changes. It just calls itself over and over and over again. Now what we want to do is at each recursive calls, decrement I by 1, or subtract 1 from n. So that way we pass an n, let's say n is 5, we subtract 1 from n, so n is 4, and now we call some recursive with 4. This method call then subtracts again 1 from 4, so it would be 3, and then calls some recursive with 3. And then some recursive 3, it would subtract 1 from 3, it would be 2, and so it would, at each method call, at each recursive method call, it subtracts 1 from n. So n will be counted down. Now when do we want to stop? That's where the base case comes in. So here I declare the base case. In this case we check if n is less than or equal to 1. And in this case I return n. So this serves the purpose when we pass in 0. 0 is less than 1, so it would return 0. But if we pass in 1, 1 is less than or equal to 1. In this case, it returns 1. So there are two base cases that I'm covering, 0 and 1. Now let's look at the recursive case. So what this does is it counts down 5, 4, 3, 2, and 1. When we hit 1, we hit the base case and we return. But we don't yet have this operation. What we do have is we have n, we have the condition, which is the base case. Now here the base case is defined when to stop. The loop defines when to continue. That's why it looks here I is larger or equal to, and here it looks n is less than or equal to. So this is when to stop. In the loop, it's when to continue. We also have the decrement operation here with n minus 1. What we are missing is the total, adding up to it. What we do this here is we return n plus whatever the method call returns. So let's take a closer look how this works. Let's say we call some recursive and we pass in 5. Now 5 is not less than or equal n, so we'll hit the recursive case, and the recursive case defines n plus some recursive and n minus 1. So n minus 1, 5 minus 1 would be 4. Now this was some recursive with 4 would result in not hitting the base case, so it will be 4 plus some recursive and 3. And some recursive 3 would result in the recursive case, which is 3 plus sum recursive and n minus 1. So that is sum recursive 2. And sum recursive 2 would result in 2 plus sum recursive and 1. Now that we pass in 1, we will actually hit the base case. 1 is equal 1, so it hits the base case, and this would return 1. Now we call all the way back up. So this returns 1. So now we are at this position here. So 1, 2 plus 1 is 3. Then at the previous method call, we have 3 plus 3, which is 6. Then we have 4 plus 6, which is 10. And then we have 5 plus 1, which is 15. So let's see and call this from the main. So here I declare a variable sum2. I call sum recursive. I pass in n. And then I also add a print statement where I print out the result with a recursive and output sum2. Now let's run this. And here we get 15 as well. So the difference is, in an iterative solution, we use loops. In a recursive solution, we use recursion using a method, a base case, and a recursive case. The recursive case covers two things. It always has to have an update operation where we decrement and get always closer to the base case, and it has an operation, an arithmetic operation that we are performing. Now, what happens if we forget to decrement here, or forget to update our counter variable? Now, if we forget it in loop, we have an infinite loop that runs forever and ever. It does not stop. In a recursive solution, when we forget to update the counter variable here, it does not run forever. The reason is that we have a method call, and each method call gets pushed onto the stack in memory, and eventually the stack is full. So let's try this out. Let's say I don't update n, and I run this program again. And here, what we can see is an error, and this is stack overflow. So the method stack overflows. It runs out of memory. So that is a different error that we would be getting if we forget than if we were to forget the update operation in a loop. So again, to sum up recursion, you need a method, you need a base case, when to stop, and the recursive case, where you update the variable and you also perform some operation that produces the result. I hope you enjoyed this video. Thank you for watching.